In this lecture, I'm going to solve some very relevant problems for upcoming JEE 2024, and here we go with the first problem. Let P be a constant. Consider the third degree equations as follows. Let Fp be the product of largest real root and the smallest one. In case there is only one, Fp is defined as the square of that root, and that makes sense. First part is to evaluate the minimum of Fp as P changes. Second is just give a rough plot of graph of Fp. So how will you solve the problem? Clearly for a given value of P, we'll get a root. So let's analyze this given x cube minus 3x equals P. If I consider LHS as f equals x cube minus 3x, so this derivative is going to be 0 at 2 points x equals plus minus 1. Hence we have found the critical point for this function. And the roots of this equation, x cube minus 3x equals 0 will give x equals 0 or x equals plus minus root 3. So 0 and plus minus root 3 is going to be root. So roughly we know we can plot the functions as follows. At 0 function will die. It will have a local minima at 1. It will increase monotonically. Similarly at minus 1 it will have a local maxima. It will decrease. And it will go to minus infinity. Right. Now as P changes, we'll have different configuration. So for the tangential case, for this height at minus 1, the height of the function that we are getting is 2. We can simply put in the function and check. At 1 we are getting minus 2 because of the symmetricity. Moreover, you can notice the function is an odd function, x cube minus 3x. So let's say for P equals 3, we'll have only one point of intersection. For P equals 2, we'll have exactly two distinct roots. So here roots will be repeated. Okay, so we'll have some maybe alpha, and this is minus 1, minus 1. For any value of P lying between minus 2 to 2, we'll have clearly three distinct roots, alpha, beta, gamma. At P equals minus 2, we have again a repeated root 1, 1 and some gamma. For P less than minus 2, if we go below, for any value, we'll have exactly one real root. So roughly I can tell the number of real roots will be 3 when mod P is less than 2 or equal to 2, right? So I'm not talking about distinct real root, because even if when mod P equals 2, which means plus minus 2, in that case we'll have two roots repeated and the third will be different, right? As shown here in this peak. And it will be 1 for mod P more than 2. So this will be the rough estimation of the cubic. Let's move further. So we'll take case 1 and mod P is less than or equals to. By the way, what does f of P means? F of P is product of largest real root and smallest real root. So let's say if I calculate f of 0, what does it mean? You put P equals 0, that will give a cubic x cube minus 3x equals to 0. It has 3 root, 0 plus root 3 minus root 3. Largest is root 3, smallest minus root 3. Multiply them, that's minus 3, and that's the value of f0. Right? So f0 is minus 3. Similarly, let's say if I find f of if I find f of 2. So f of 2 means x cube minus 3x equals 2. And we'll have clearly two solutions, minus 1, and some alpha. And that alpha is nothing but 2, which you can easily check. So what will be the product of these roots? Product of minimum is minus 1, maximum is 2, so f2 is minus 2. So like this, for every value of P, we'll have the value of these functions. Okay. So for any P between minus 2 to 2, or in fact equal to that, I can assume we'll have 3 roots, let's say alpha, beta and gamma. Without any loss of generality, one will be highest, it will be lowest and so on. So let's call this point to be alpha, this is beta, and this is gamma according to the diagram. Now what will happen here? So smallest is alpha, largest is gamma. So Fp is given by alpha gamma, which can simply be written as alpha beta gamma by beta. Alpha beta gamma is nothing but P by B, because alpha beta gamma product of root from this cubic is minus B by A, C by A minus D by A, which is P. So what does P by beta represents? Now P can be written in terms of beta, because we know beta is the root of this equation, hence beta will satisfy. So beta q equals 3 beta plus P, and hence P can be written as beta q minus 3 beta over beta, which gives beta square minus 3. So for any beta lying between alpha and gamma, Fp for P lying between minus root 2, we have this functional relation. Now, is there any restriction on beta? Of course, yes, because you know these roots will definitely be in between minus root 3 to one root is less than minus root 3 and other is more than that, right? What is the restrictions on beta? Now restriction of beta is quite clear, because for values of beta, which is, you can clearly see the beta will lie in the interval of minus 1 to. From the diagram, it can clearly be seen the beta is the point of intersection of the curve at some constant y value. So you pick up any y value, the range of beta is going to be minus 1 to 1 in this interval, right? So let me draw this diagram for the function. As you can clearly see, if I cut this function at any point, okay, the mid root beta is definitely lying between this window minus 1 to 1. So you can cut over here, as long as it has got 3 distinct roots, right? Because this is the ultimate barrier, so beta will flow between minus 1 to 1, and that gives very nice result of this. As beta is dancing from minus 1 to 1, I can tell this expression will dance from minus 3 to minus 2. Hence the minimum value of Fp is going to be minus 3 in this interval, right? And that will happen at beta equals 0, which means P equals 0. Let's analyze case 2. If mod P is more than 2, under this condition alpha is the single root, right? Because graphically, if any value of P is more than 2 or less than minus 2, which is captured here, we'll have just one ring or real root alpha. Other two root will be imaginary. So under this case, Fp as we have defined is alpha square. Since alpha is less than minus 2, alpha is more than 2, right? Hence we can tell still Fp is going to be more than 4. So therefore minimum value of Fp, minimum overall, is nothing but minus 3. Okay, so the region where alpha is greater than 2, because we know this height will be attained at x equals 2. Okay, so the height of 2 is also attained at minus 1, and 2 value. So any values of y equals p is going to intersect the graph at exactly one root after x equals 2. Hence alpha will be more than 2 or alpha is less than minus 2. So that justifies that thought. And now we are ready to plot a diagram. That's really simple. So if I'll plot, let's say y versus p, as p changes, what's happening? Minimum value is minus 3 over here, and is parabolic, beta square minus 2 type. So at p equals 2, and then suddenly just after 2 plus, it's gonna be 4. Because of symmetricity of the situations, this will be the rough picture. And the function Fp is discontinuous at plus minus 2, and of course it's non-differentiable. So maybe they could have asked you number of differentiability or number of point of non-differentiability in G. Let's move to the next question, and instead of writing the question, I'll explain the question. On Z equal to C plus 1th floor, for some constant C, we have a circle x square plus y square equals 1. Now there is a torch light, there is a source of light which is attached to this circle, and the source of light is moving along the circle. Okay, we have a small film at the we have a small rectangular film on Z equal to Cth floor, means at Z equal to G, and the boundary of this is given by mod x is less than equals 1 and mod y is less than equals 1. So this is basically a small slit. As the source of light is moving, of course for any particular location of this light source, this slit will make a projection, or its image will fall on xy plane, right? And as you can clearly see, this image itself is going to be, its image is going to be fall on xy plane. So as you can see, its image itself will be the extended version or a scaled up version of the slit available. The question is, you have to find the area of the projected region as the point P, which is source of light, is moving around the circle. Of course, this question can be converted into an ellipse also. Instead of circle, I would have given you ellipse. And instead of this slit equation mod x less than equals 1, mod y less than equals 1, and z equals c. So instead of this, I could have given you mod x less than equals a, mod y less than equals b, and the equation of circle I could have made ellipse. So this is basically, you could have de-scaled the problem by taking x by a as a new variable and do exactly in the same manner. So let me consider the case which I am discussing now. How to find the union of the sided area as point P is moving along the circle. Okay, so before we go and track this problem, it's better, let's see one of the particular situation. Now let's see, for any particular position of point P, I can write the point P as maybe alpha, comma beta, and comma c plus 1, right? So let's see, for that point, a particular location for the torch, how this plane behaves. Okay, so the midpoint of this rectangular region, in fact a square region, is 0, 0, C, which is the center of this square. So where will be the image of this square? It will definitely be the image of the projected square will also have the corresponding midpoint. Okay, so this will be the midpoint of the projected square. Let us calculate the midpoint of projected square by projecting the center of the square at z equals c. So we'll just write the equation of line. We know this point is going to be something x, y, comma 0. The point P is alpha, beta, c plus 1, and the point, the center of the slit is 0, 0, c. So I can write the equation with point P, center of slit. Equation of line is nothing but x minus 0 by alpha equals y minus 0 by beta equals z minus c by c plus 1 minus c. And now we know any point x, y, g on this line will satisfy this relation. So if the point happens to be on xy plane, I'll put x equals x, y equals y, and z equals 0. And that gives me a very beautiful result. X equals minus alpha c, y equals minus beta c. So what does it tell is the center of the projected square is going to be minus alpha c minus beta c comma 0. Now you can easily check, like if I take this point and other corner of this square, so what will be the corner? It's going to be x equals minus 1, if y equals plus 1, and z is still c. Similarly, this corner is minus 1 c. The other corner is going to be 1 c. The last one is 1 minus 1 c. So for all these four corners, we'll have these four projections, which is very easy. You can just either write this vector is equal to some lambda times of this, or write the equation of line containing point P and the points on the corner of the slit, and put it again x, y, 0 to find these coordinates again. Once you'll find four coordinates, you will see the projected square is nothing but an enlarged version of that square. By what factor? That of course you can do by finding these points and relating this into this, the area of this parallelogram with the area of actual square. So in this case, the parallelogram will turn to be a square, the projected parallelogram, but it will be simply c plus 1. The reason is because we can simply use similarity. So the ratio of length will be equal. So what is this distance by this distance? So let me redraw the diagram. So we have x, y, z axis. We're having a circle, another plane. We're having a small slit. And if I take a particular configuration, we have some squares, projected square over here. Okay, so from this diagram I can clearly see, let's say that point is P, the slit, this point is Q, the projected point is R. So now I can tell PQ by PR, PQ by PR is same as these squares dimension. Okay, so it is same as, because in this triangle, let me name it R dash, Q dash, P. So PQ by PR is same as QQ dash over RR dash, and that in turn will be same as the distance between these planes, because their height h1 divided by distance between the point P and the xy plane, so h2. Now what is h1? Distance between these two planes, nothing but c plus 1 minus c, and by the total perpendicular gap is c plus 1, hence it's 1 by c plus 1. So hence what we are getting is PR is c plus 1 times PQ. So every length is just scaled by c plus 1 factor. So it was a square of unit length, so this will be a square having area c plus 1 whole square. But this is the answer for one particular configuration. Okay, so for one particular configuration of P, the square will have a center Q, and the center Q is nothing but along it will be the projection of the center of the slit. Now what will happen as this point P moves? Of course, as the point P moves, the center Q will also move. And what will be the locus of Q? As we have found from the earlier result, the Q coordinate is given by minus alpha c minus beta c comma 0. And you can clearly see, if I eliminate this alpha and beta, as we know alpha square plus beta square is 1, it is an unit circle. So we get x square plus y square equal to c square. It means the point Q itself moves in a circle as the torchlight start moving on a circle. And what is point Q? Remember, it's the image of center of the slit. So at point P moves, as the torchlight moves, its image as the point P moves, the image of the center of this torchlight also moves in a circle. And that circle is x square plus y square equal to c square, z equals 0. Okay, so now for all configuration, we have to find the union of area. And that is really interesting. You can little bit play, because you know, for one particular location it was c plus 1 and c plus 1. Okay, now what will happen if q is moving in a circular region? So for the extreme position of q, I still will have, you know, like this distance as c plus 1 by 2, and this guy is gonna be c plus 1 by 2. So roughly a square will come here, right? Now if we'll take all these four configuration, so you can draw a square, right, which I want you to do by yourself. And if you see the overlap of all region, basically you can add the area of this circle with those four square plus some extra quantity, and that's gonna give you a remarkable result, which will come as pi c square plus 4 times, because these are smaller chunks, only 4 times c plus 1 whole square, plus that extra part that will get is 8 c into c plus 1. So this I want you to, you know, like draw and to get the area of the union of those projections. I hope you must have enjoyed this problem, and it was really challenging as well as visual. Go with the next problem. Let Sn is the sum of n terms of AP An, which means the AP terms are A1, A2, n. If S15 is positive and S16 is negative, you have to find maximum of this expression. Now, what does this expression decodes to? Maximum of as n is changing from 1, 2, 3 to 15, the value of Sn by n. So if n is 1, it will be S1 by A1, for S2, S2 by A2, S3, S3 by A3 till 15. So S15 by A15. So out of this, all this expression, we have to find max of this. So this is still a very new problem from arithmetic progression, which is recently a trend in J-Advance. As you will see the last 3 to 4 years paper, there is more number of problems on AP than on GP and HP. So let's see the solutions. Let D be the common difference. So clearly A1 can be written as A8 minus 70, because A8 is A1 plus 70, right? What about A2? It can be written as A8 minus 60, and so on and so forth. A15 can be written as A8 plus 70, because the gap will be same, right? A1, A2 till A15. These gaps are common, hence the difference is common, hence the name derived is common difference. Now we know since A1 plus A16, because to get around 15 and 16 sum, we're trying to is same as, because first plus last is same as A2 plus A15 according to this. So S15 is 15A8, right? So 28 plus D. So from here what we can conclude is X16 is 8 into A8 plus A9, and since that's less than 0 and A8 is already positive, so A9 has to be less than 0, right? So that gives a conclusion for A9 to be less than 0. So finally D we got A9 minus A8, which is less than 0, hence A1 must be A2, must be greater than A3, so on till A8. So till A8 all terms are positive, right? Now what about A9? So A9 is less than 0, and A9 bits A10, and so on and so forth till A15. So this is a sequence of numbers that we got. So from here, straight away we can conclude is S1 is more than 0, and S2 till S8. That will be one sequence. And from, because you know, like just these terms are being added. What is S1? It's A1. S2 is A1 plus A2. S8 is A1 plus A2 till A8. And since common difference is positive, so this will keep on adding. No, and what about from S9? Since common difference, you know, like that's less than 0. So after S8 it will decrease. So I take S9 till S15, that summation will get 0. So this implies S1 by A1 is less than S2 by A2 and dot S8 by 8, and 0 is more than S9 by A9, S10 by A10, anyway S15 by A15. So coupled with these two results, I can clearly see the maximum value that I am getting is S8 by 8. Of course, this was an unusual way of solving this problem just by analyzing the information. What you could do is directly use the sum of terms of an AP, write an expression of Sn by n, and try to simply use like either basic calculus or simple AMGM, or you can use a quadratic to minimize and maximize. Hence S8 by 8 will give you maximum value. Before I give you a hint, so we have an ellipse with 16 and 4 as a parameter, so it's 4 and 2. Of course you will calculate the focus. Left focus, let's say f1, right focus is f2, and you have a line. This line is having positive slope, so let's call this line is L. Now the question is, we have a variable point P on this line such that f1P f2, this angle, let's call theta, is maximum, right? So as P lies on this line, or as P moves on the line, there will be some configuration, some location of point P on the line for which this angle will be maximum. Under that condition, we have to find the ratio of this length, Pf1 by Pf2. Now before we go and hit the problem, let's try to understand why the question setter even asks that f1 Pf2 will be maximum. As you can clearly see, let's say if you are somewhere here, you'll have some angle theta, right? Theta 1. As you are changing on the curve, these angles keeps on changing. And you can see clearly as you move away from the ellipse on the line, the angle keeps on decreasing. At infinity, what will happen? At infinity, we might feel like the angle is almost 0, because these two lines will feel like all these three lines will become parallel to each other. So roughly if I'll plot, and similarly at this side also, angle will keep on decreasing for any point. So at minus infinity somewhere its angle is 0. So if I see what is happening to theta versus the location point P, so at minus infinity is going to be 0, at infinity is going to be 0. Now is it symmetric? No, because if the line L would have been parallel to the ellipse, parallel to the major axis of ellipse, then clearly for this point we would have got some maximum value theta max, and as point P is moving, the angles continuously decreases, and the situation is completely symmetric at origin, right? So something like this graph will come. But in the present case, the situation is more interesting, and a qualitative feel of the question will be at minus infinity is going to die. Okay, not only, it will also die at this point. So at some location x equals minus, that you can easily calculate at minus 8 minus 2 root 3, that x values. Okay, so let's say theta versus x, and still the angle is dying. So we'll have death of angle here, death of angle at minus infinity, and death of angle at plus infinity. So we have 3 points where the value of function will almost be 0. Okay, so how the graph will look like. So now at minus infinity it will be 0, but it's gonna be 0 at still some point, which is minus 8 minus 2 root 3. So it will come like this. It will have a minima, or it will die, and now we know it will die at infinity 0. So qualitatively I know there will be two maximum values. At this location we'll have some theta max, this maximum height, and even at some negative location we'll have theta max. So out of these two maximum value, the one which gives maximum angle will be the corresponding, qualitative picture where maximum value of theta is achieved. This can be easily seen because it's 0 over here, and again it has to go to 0 at minus infinity. So the angle must be somewhere, first angle must increase and then decrease. And that you can easily see because 0, as you are increasing, first angle is increasing, and effectively at minus infinity still has to die. So without calculus, we know the roughly the theta versus locations will more or less be like this. Now of course you can tell like I have to calculate the ratio of this quantity pf1 by pf2 for both of these locations, right? So what I'm going to do is I'll just calculate for these locations and you can repeat the same thing. It might happen like for both these locations, although pf1 and pf2 is changing, but their ratio is intact. It might happen, I'm not telling will be. So that you can just calculate and check by yourself. Now one way, so till now I've not done any solutions, right? So one way of solving this question is directly you can take a parametric point on the line in terms of t. So if x is t, y will be really bad, not too bad, not to handle. This one. And now we know the slope of f1p and f2p. So m1 and m2 is known as a function of t. I can use this theta with n theta formulas, m1 minus m2 by 1 plus m1 m2, plug those values in terms of t. Okay, and to get a maximum value of theta, of course we have to maximize tan theta. That will happen because here you can see theta is acute. So if theta is between 0 to 90 degree, of course I tell as theta increases from 0 to 90, the functions will also increase. That you can't tell after 90, okay, because here from the observations clearly all angles are acute. So to maximize the theta, theta has to be maximized. So just differentiate that, make it 0, and you get two critical point, and that qualitatively which you are seeing from the graph. But there is a nice way of escaping all this because the calculation will be too clumsy. So let's consider the family of circle which is passing through S1 and S2. I'll justify why this idea came all of a sudden, why we went to family, right, out of nowhere. So how many circles we can make to pass through this? Of course infinitely many, right? Okay, let's say a circle, if it cuts it at point P and Q. Now the angle that this focus f1 and f2, here let me change the name, f1 and f2, max at the point Q is let be theta. So of course it will make the same angle at point P as well, theta, right? Just for the sake of clarity, I am deleting the remaining circles. So let's delete the remaining one, and we are left with this situation. Out of many families, there will be definitely many guys which will be cutting at 2 points, right? Now what is the speciality of point P and Q? Point P and Q are special in the sense like they make same angles on the line. But as I move along the curve, will the angle be constant? Of course no. Why? Because as we are moving along this arc, the angle will be constant at theta. So let's say for any particular location on the arc, if I calculate this angle, that will still be the theta. So if I move down, it's common sense, if I'm moving down, the angle will be more than theta. So my journey on the arc is constant angular journey, but the journey along this line is not constant. So what's happening between this interval Q and P is how angle is changing. So it's theta over here, and of course it's increasing, and then again it's coming back to theta. Okay, so there exists some point between Q and P at which theta will be maximum, and that gives me more grid. It means if I can make this window PQ more smaller using mean value theorem, I can capture that between these two intervals, right? Or using common sense, whatever, forget about mean value theorem. So what I tell is, let's say I draw another circle, family of circle passing for this focus. Okay, so now the angle that this f1 f2 is making is clearly more than the previous angle of even theta max, right? So now I'm beating the previous angle. So let's say now it's again some theta special, and again at some different location also it will be same theta special, but still my journey from Q dash to P dash in that small interval is going to be, there will exist Again, my journey from that a small interval, let's say q dash to q dash, there exists some point for which theta will still be more than this theta special. So still I have found one more larger value of theta. So by doing this again and again, now you know in the limiting case, we'll have a special maximum value of theta, and the circle passing through f1, f2 will be tangential to this line, and that gives a clue to solve this problem. Okay, so among all possible situations, the one when this family member of circle is tangential to the line, given line L, will give theta max. Now once this is done, you don't need to find point. One way is to maybe we already know this angle of line with the x-axis, so you can use parametric form. Is not root 3 comma 0, but rather is minus 2 root 3 comma 0 comma 2 root 3. Hence this distance is 8. Hence this distance will be 8 plus 4 root 3, and the other AF2 distance is nothing but 8. So if you multiply, you'll get the value of AP. Once you know AP, you know this distance R, H plus R cos theta and K plus R sin theta. You will easily get point P. But once you know point P, again, you can calculate this distance, find the ratio and get the answer. But is there any special way in which I can escape the point P calculation? Of course, yes. As you can see, since this guy is behaving like a tangent, so if this angle is psi, so angle AP F1 is psi, then this angle is also psi. This is because of alternate segment theorem, and that can be proved very easily. Let's say if you have a tangent to a circle from a point P and a secant which curves at Q and R, so angle that this point, you know, the line segment QT makes with tangent, let's say theta, it will be same angle as TRQ. The reason being, so this is theta, let's say somewhere we have center. So if I join the center, this small chunk of angle is 90 minus theta. Hence this small chunk OQT is also 90 minus theta. Hence angle at center is 2 theta. Hence angle at R is half of this, which is theta. So for this is psi, this will be psi. Hence two of this triangle are similar. Now when it is similar, I can say F an angle A is common between both of them. So PF1 divided by PF2 equals opposite to psi, which is AF1 divided by AP. Now how to calculate AP? And we know AP A square by Ptolemy's theorem. PA into PB is PT square on a circle. AP square is going to be AF1 into AF2. Square this expression. So PF1 square by PF2 square is gonna be AF1 square by AP square, and AP square is AF1 into AF2. So you can simply cancel this, and we got AF1 by AF2. Now what is AF1? Just now we have calculated is 8 plus 4 root 3, and F2 is 8. So this can be written as 4 plus 2 root 3 over 4. Now 4 plus 2 root 3 gives us a filling of 2AB, so 2 into root 3 into 1. And we know root 3 square plus 1 square is 4, so 4 can be nicely written as root 3 square 1 square plus 2 into root 3 into 1 over 2 square. And that is nothing but root 3 plus 1 by 2 whole square. Hence